Hi there and welcome back to the Good Tutor Premier Prep SAT course. In this video, we're going to continue our look at the Passport to Advanced Math subsection of the SAT math portion, and specifically continue our look at functions with an introduction to the different ways you can see functions be presented on the SAT. Alright, so to give an introduction to functions, functions are rules that feature inputs and outputs, as we talked very briefly about in the last video, with a unique output for an input. I always like to liken them to machines because you have something that goes in and you have something that comes out after you put something in. So if you have that input, which is that x value, it goes in, it does all the operations of whatever the function says, and then it comes out as a different number, the output or the y value or the f of x value if we're talking in function notation. An important part to remember, and we'll look at it in the first example that we do actually on the next slide, is that the input values of a function will never, ever repeat. Because if they do, that means that when graphed, two lines will be on top of one another as far as vertically. So if we were to run a vertical line through them, that line would hit both of those points with the same input or same x value. And that's what's called graphically the vertical line test. So if input values ever repeated on a function, or I should say on a set of numbers, it wouldn't be a function because again, when graphed, it would fail the vertical line test. So to speak on a couple terms that we saw as well in the last video, domain and range, every function has both a domain and a range, with domain being the set of all possible x values of the function and the range being the set of all possible y values. All right, so now we're going to look at three examples, the first of which will have us build a function. All right. So the first example gives us a chart here with some x values and some z of x values, aka y values, right? So x and y values of the function z are displayed in the above table. Which of the following defines z? So now we're given four functions, and we can tell that they're linear functions, right? Because they're in the form y equals mx plus b. Each one of those four is in that form, actually, a through d. And now we have to find which one of those applies to the data that we have here. So the best way to do that is actually to use the data that we're given. Use one of the points that we were given to find which of these applies. And that's known on the SAT as back solving, meaning you use an answer, you basically pick an answer choice and plug in values. And on this one, you're just going to plug in the values actually provided in the problem into the answer choices. So if we use that first point, x value of 2, y value of 9, that's the point 2, 9. We're going to just plug in 2 for x and y, 9 for y, into each of these and to see which one is true. And whichever is true, if it's only one, we know that that's our answer. So if we look at this first one, 4x, so in this case, 9 would have to equal 4x, which is 2, plus 3, which of course would be 8 plus 3, which is equal to 11. And 11 does not equal 9, so it is not A. All right, let's try the next one. In this case, 9 would have to equal 3 times x, which is 2, plus 4. In this case, that would be 6 plus 4, which is equal to 10, which once again does not equal 9, so the answer is not B either. If we get to C, now 9, still y, has to equal 4 times x, which is still 2, minus 3, which would be 4 times 2 is 8, minus 3, which would be 5, which once again does not equal 9. And now let's try our last one. 9 would still have to equal 3 times x, which is 2, plus 3, which in this case, 3 times 2 would be 6, plus 3 equals 9. So, yep, 9 equals 9. So, D, or z of x is equal to 3x plus 3, would represent the data that we were given in the problem. All right, so now we will go ahead and move to the next example, which is going to have us look at graphs, and specifically use function notation when looking at those graphs. Okay, so we're asked in the given graph, what is the value of z of 2 plus 2, and then parentheses, h of 8 minus h of 3? All right, so now we have these two functions. We have one actually that's a parabola, or a parabolic function, right? And then we have one that's a linear function, h of x. Z of x is actually the parabola there, right? So, and that isn't really too important because we just have to see where the functions are at given values. So let's start with z of 2. So z, again, the z of x function is the parabola, the one that sort of curve. And so we're looking for z of 2. If 2 is inside the parentheses. That means that 2 has replaced x because it's z. The function is z of x, right? So we're looking for what is the y value of the z function when x is 2? Well, let's see. Well, here is the 2x value, right? If we go up and see where that one is, it looks like 0. Because when our y value is 2, which is 1, 2 from the origin in the middle there, that z value is at 0. It's at a 0 y value, so it would be 0 plus 2, and then now we have to find h of 8 and z of 3. All right, so next let's look for h of 8. So h, of course, we said was the line, right? It was the linear function in this case. Now we have to look for the y value when x is 8. So if we look from our origin again, 1, 2, 3, 4, 5, 6, 7, 8, that would be this x value. Where is the y value? If we go up and check, we see that it is at 4. So in that case, h of 8 would be 4 minus, let's see what z of 3 is. So now we go back to the z function, which is that parabola. And we see where is that function when x is 3. So x is 3 is there where I just circled. And then if we go up to see where that parabola hits, it is about at a 3y value as well. So z of 3 would be a 3 as well. All right, so now it looks like we have everything we need, right? So now we have 0 plus 2. And then inside the parentheses is 4 minus 3, which would be 1. So 0 plus 2 times 1, which is 2. And the answer to this entire thing would be 2. So again, using function notation there, we were given 3 different, actually, x values within the given functions, and we solved for the corresponding y values, and then combined them how we were supposed to according to the problem, and got a final value of 2. All right, the last way you're typically going to see functions is in the form of word problems, and we're going to take a look at one here and solve. All right, so William is writing a 40-page play for his theater class. He believes he will average 35 words per minute while typing the manuscript. If a single page is around 300 words, which equation best estimates the number of pages remaining, p, as a function of the number of minutes, m, that William types? So here we're looking for basically the number of pages that he has left the more he continues to type. So essentially at what rate is he finishing this and how many pages are left as he does, okay? So the first thing that we have to look at, if we're looking for the number of pages remaining, the first thing I would do to eliminate answer choices I know automatically are wrong are look at what does that ask? Where did we start as far as pages? So what's the maximum number of pages that we can even have to start? Well, the answer is 40, right? Because it's a 40-page play that he's writing. So we know that we're going to start with 40, all right? Which means right off the bat, we can eliminate B because we don't need to start with 35. And then we have to ask ourselves, okay, we're asking, what is the problem asking? It's asking for the function of P, which is the number of pages remaining as he types. And we have to think about that conceptually and go, okay, as he types, there's going to be less and less pages remaining because he's finishing pages the more he types. So it would be 40, take away something, right? The 40 pages minus whatever he's doing, minus the number of pages, because again, he is completing them, and as time goes on and as he works more, there are less and less pages left, which would also then eliminate D, leaving only the possibility of A and C. All right, so from here, we have to ask ourselves, okay, how do we figure out how much he's actually doing? So let's ask ourselves first, what rate is he completing this at? Well, we're provided that he's working at an average of 35 words per minute. 35 words per 1 minute, like that, right? From there, we see how many pages or how many words are on each page. We find that there are 300 words. And what we're doing here by setting it up the way we are is getting it so that we can cancel out terms. So in this case, see, words is up with 35 in the numerator of the first one, and then of the second one there, it's in the denominator, which means as we multiply across here, the unit of words will actually cancel out. So 300 words is 1 page. Right. So from here, now we have, if we multiply straight across, we have 35, and then words will cancel, 35, because that was 35 times 1, over 300 times 1, which is 300. All right, so we have 35 over 300. And now if we simplify that fraction, we can actually divide both of them by 5. And you'll see that that final fraction is 7 over 60. Which now we have to multiply that 7, of course, by the number of minutes that he works, because that's going to be his rate, right? 7 times the number of minutes that he works over that 60, which represented that originally the 300 words. It's just a simplified version of the 300 words per page. And then the 7, of course, is the simplified version of the 35 words per minute. So in this case, we have 7m over 60, which would reveal A to be our correct answer. All right, and that is it for this video. And in the next video, you'll actually get out of functions and head into radical rules that you'll see on the SAT.